Thank you for joining this lesson. We're going to discuss X-rays, and it's good for you to know that X-rays is part of the electromagnetic spectrum. Therefore, it is an electromagnetic wave, and we're going to study X-rays by beginning with the production of X-rays, which happen in the X-ray tube. Therefore, this is the X-ray tube. It has several parts, but I'm going to discuss the major parts together with their functions and everything that pertains the production of X-rays. Therefore, I will discuss the parts as I mention how the production of X-rays takes place. One, we have a filament supply. Let me use a different ink because I can see they have used black. Let me even apply red. Yes, we have a filament supply. It's good to know that on the filament, which is supplying current on the focusing cathode, there is a potential difference. This is the potential difference which ensures that current has been supplied to the cathode. And the cathode being metallic, we usually say that this current creates what we call an heating effect at the cathode. It is this heating effect which ensures that the electrons at the cathode gain enough kinetic energy, and once they gain kinetic energy, they are able to get dislodged from the metal surface. Now, this dislodging, or rather this emission of electrons from the metal surface through heating, is what we call the muonic emission. So briefly, we can say by the process of the muonic emission, electrons are emitted from the focusing cathode. Now, once electrons have been emitted, you can see this is a stream of moving electrons, a beam of moving electrons. It has been labeled here. So the beam of moving electrons is attracted by what we are calling the anode. Actually, it's made of copper. Sometimes they call it the copper anode. The copper anode. Therefore, the copper anode attracts what we call the beam of electrons. And now, once the beam of fast moving electrons hits the target, the copper anode has a target which is made of a material called tungsten. Once they hit the tungsten target, the energy is converted, and part of it becomes heat energy at the anode, and a small percentage, which is 0.5% of the energy of the moving electrons, becomes X-rays. Therefore, 100% of the kinetic energy, 100% of kinetic energy of electrons is converted at the anode, and 99.5 becomes heat energy, while a small percentage, like 0.5% of the energy, becomes X-rays. Therefore, now, when the fast moving electrons are attracted to the anode, energy conversion takes place. Energy conversion takes place. A bigger percentage becomes heat, and a small percentage becomes X-rays. Now we have the X-rays channeled through the window. This is called a window. This is a window. So through the window, we have the X-rays coming out. It's good to remember that due to the penetration power of X-rays, they cannot be produced and stored. They get produced at the time they are being used. Therefore, we'll see the several uses, but now immediately they are produced, they are projected outwards through the window to the intended purpose. It's very good to note that the heat energy which gets produced at the anode has to be dissipated away. That is ensured by the copper anode. Remember, copper is a good conductor of heat energy. It's a good thermal conductor. Therefore, it helps to conduct the heat away. There is also a system of cooling fins which assist in the process of dissipating the heat away. It's also very good to know that we have a vacuum here, a vacuum in the X-ray tube. And this is to ensure that once the electrons are moving, they don't collide with other particles along their path as they get attracted towards the anode. Remember, collision with other particles on the path might lead to loss of energy, and that means the X-rays that will be produced at the end of it will also be having low energy. So to ensure or to conserve the energy, we have to ensure that the X-ray tube is evacuated, or rather it has a vacuum. That prevents loss of energy by the moving electrons. It's good to mention that there is a very high potential difference. Remember, the cathode, it is a negative potential, and the anode is at a high positive potential. So there exists a very great potential difference between the cathode and the anode. This is to ensure that the electrons which are produced at the cathode are accelerated towards the positive anode. Therefore, the high potential difference between the anode and the cathode ensures that there is acceleration of the produced electrons from the cathode to the anode. There are two potential differences in this case. We must be very careful with them. There is a potential difference that ensures that current has been supplied to the cathode, and now there is another potential difference existing between the cathode and the anode. Actually, in some cases, this one is even from a step-up transformer. This one sometimes is from a step-up transformer, such that we have a step-up transformer at a point like that, such that now there is a great potential difference that is connected to the cathode and to the anode to ensure that electrons are highly attracted. Something else to mention is that there is a lead, they are calling it lead housing, to absorb X-rays emitted in unwanted directions. Sometimes they call it a lead shielding. We call it a lead shield. Now, the lead shield you see here ensures that in case there are stray X-rays, because X-rays have some dangers, when they are not in the desired direction, these X-rays can even enter into body cells and they cause harmful effects. So to eliminate that danger, we use lead shielding, which has very high density and ensures that the X-rays do not penetrate except through the window, which has been left here. Therefore, lead shielding ensures that stray X-rays do not penetrate into unwanted directions. It's good to also mention that the target is made of tungsten, which is a material of very high melting point. And this material of high melting point ensures that it is able to withstand the great heat energy produced at the anode. So at the anode, I mentioned the energy conversion, whereby the total kinetic energy is converted to heat energy and a small percentage becoming X-rays. So the great heat energy produced has to be taken care of. In case we use a material of low melting point, it can end up being melted by the great heat. So to avoid that, we use tungsten, a material of high melting point. Alternatively, we can use a material called molybdenum. Working of the X-ray tube, these are things we have already mentioned. When the cathode is heated, it produces electrons by thermionic emission. So whereby current is applied to a conductor, then the conductor, there is what we call a generation of heat, because we all know that current has heating effect. Therefore, the heat produced now makes electrons to get emitted. We are saying the emitted electrons are accelerated, strongly attracted to the anode, or rather the target, by the high potential difference between the anode and the cathode. Then when the fast moving electrons are stopped by the anode, that is the target, part of the kinetic energy is converted to X-rays. It's very good to say that the other part becomes heat. So the other part of the kinetic energy becomes heat energy. Then the cathode is concave in shape so as to focus the beam of electrons to the target, and it is a tungsten target. We can continue and say that the anode target has high melting point. That is the material called tungsten to withstand a lot of heat generated. Then I will continue with the working and say that most of the kinetic energy of electrons is converted to heat, but about 0.5% is transferred to X-ray radiations. Then we can also mention that the anode is made of a good conductor of heat, that is copper, for dissipation of heat energy. However, oil circulation and cooling fins, which are also made of copper, we have copper cooling fins, which enhance the cooling process, together with oil circulation and the anode being made of copper. Lead shielding has high density so as to prevent X-rays from penetrating into undesirable targets or other directions. So lead shielding has high density and it can absorb the X-rays which are stray without allowing them to penetrate through. Modern X-rays have a rotating target during operation to change the point of impact, thereby reducing the wear and tear on it.